Hey judges, we're Team ZASP, and we used mortgage data to find opportunities for upwards mobility in the US. So this is the Smith family. They're a really happy family, but their income is in the bottom third of all mortgage applicants.
The Smith family is looking to move up the socioeconomic ladder, and in order to do this, they're looking for three main things: access to affordable housing, a stable employment, and a strong education for their kids.
So our solution for families like the Smith family is an interactive map that shows the areas that have the most opportunity for economic upwards mobility. And we've measured this opportunity through the ZASP index, which combines the mortgage affordability index, the high school graduation rate, and the employment rate of each US county. And we've plotted this onto an interactive map where families can look at each county's ZASP index. They can look at the data from 2018, the data from 2019, as well as our future predictions for 2020.
The ZASP index is relatively normally distributed, centered around 70, similar to a classical grading distribution.
Some quick definitions before we get into the specifics of how we formulated the ZASP index. The affordability index is just defined as a quantified affordability of living in a specific home with a 30-year mortgage. The high school graduation rate is a percentage of registered freshmen who graduate 4 years later. And the employment rate, put simply, is the ratio of employed to the working age population. Additionally, some notes on the affordability index. Since we wanted to emphasize our commitment to low-income families, we sorted and took the 33rd quartile of incomes and then determined the median from there. When you put numbers into the affordability index, a score of example 120 would mean that a family earning the median income has 120% of the income necessary to qualify for a conventional loan on a home in any given area. And in order to standardize these all on a 0 to 100 scale, we assigned a flat multiplier to the data to allow us the ability to give each county code a composite ZASP score. Now, the specific math behind building the affordability index. We determined monthly payment by dividing loan amount by loan term. We determined a qualifying income by multiplying monthly payment by 4, then 12. And we determined the overall affordability index by dividing median income by qualifying income and then multiplying by 100. In doing this, we utilized a couple of columns from the finance track dataset that are listed below.
So let's talk about how we actually use the data set. The first thing we had to do was clean up the data. The data was about 30 million lines long and had about 30 columns, so we had to narrow it down quite a bit. The first thing we did was we removed the columns that we didn't need. As Shri pointed out earlier, there were only about 7 to 8 columns that we used, so we took out all of the rest. What we did after this was that we filtered out rows where the income was negative or 0, which we assume was just from erroneous data. After that, we also removed rows which had NA or exempt values. Once we did this, we grouped all of the values by county, and then we calculated the 33rd percentile of incomes. Once we had this value for each county, we went back through the clean data and removed every data point where the income was greater than that 33rd percentile, because we're primarily looking at lower families with lower incomes. After we did that, we created a mortgage summary. So we took our filtered data and then we generated median incomes and loan amounts for each county. What we did after this was we finally calculated our ZASP index. So we took our mortgage summary data set that we calculated earlier, and then we combined this with 2 external data sets. So we had a high school graduation rate data set for each county and also an unemployment rate data set for each county. We then calculated the employment rate, and then we calculated the simple affordability index that Shri talked about earlier. And we used the loan amount and income for this. And then we normalized that between 0 and 100. After that, we calculated our ZASP index, which is basically a simple weighted average. So we took 50% of the affordability index, 25% of the employment rate, and 25% of the graduation rate.
Next, we look to predict the ZASP index for 2020 onwards. First, we started with a simple linear extrapolation model that predicted 2020 ZASP indexes from 2018 and 2019 ZASP indexes. Once we completed this model, we looked to create a more complex model that would allow us to predict further into the future and use trends from further into the past. We used a model that makes use of a time series split cross-validation technique when training the model. This means it will use data from 2015 to train for 2016, 2015 and 2016 to train for 2017, and so on. Then, once the model is trained, you can use recursion to predict further to the future. Once you have predicted data for 2020, it is easy to predict data for 2021. We must make a disclaimer though. Obviously with COVID in 2020, our models will have significant inaccuracy due to these unpredictable effects. The federal government CARES Act has only further compounded this inaccuracy due to complications with people not defaulting on mortgages that they would have otherwise defaulted on without the CARES Act. Finally, the Smith family is moving to Perry, Alabama, with a projected 2020 ZASP index of 100.